everyone, I'm Svetlana Sakova, developer advocate in JetBrains. Glad to see you in this series discussing the tasks from the Advent of Code Challenge and how to solve them in Kotlin. Today, we are looking at the solution for the second day task. It works best if you first solve the task and then check the solution. But of course, you can only watch the video. It also helps to improve your Kotlin knowledge. So, what are we doing in this task? We need to validate that passwords meet the corporate policy. You can read the full story at adventofcode.com 2020 Day 2. In essence, the task comes down to the following. The password and the policy are represented in the following way. First goes the encoding for the policy, then the password. Our task is to check that the password is valid and conforms to the given policy. The policy is different in the first and the second parts of the task. In the first part, we should count the occurrences of the given letter. It should be in the provided range. The first password is valid, since it has one A occurrence, which clearly belongs to the range from 1 to 3. The second password is not valid. It doesn't contain B, but it should contain it at least once. The third password is valid. The number of occurrences of C is 9, and it belongs to the given range. In the second part, the policy is different. It describes two positions in the password. Exactly one of these positions must contain the given letter. Note that the indexing starts at 1. The first password is valid. It contains A on the first position, and on the third position stays another letter C. The second and the third passwords are invalid. The second password doesn't contain B on either of the positions, and the third one contains C on both positions, which is also not correct. Let's now implement the solutions in Kotlin. First, let's read and parse the input. We already know that we put all the logic into the main function and start reading lines from the input file. How to store the password together with the policy? Let's create a data class for that. We name it password with policy. It contains 3 properties for storing a password, a given letter, and a range accordingly. We are using Kotlin type int_range for storing an integer range. The modified data instructs the compiler to generate a bunch of useful methods for this class, including the constructor equals hashcode and a string. Let's write a function that parses one input line into password with policy class. Since it's a function that creates an instance, let's put it into a companion object to our data class. Then we can call it by the class name. While developing, you can put the todo function call inside. It throws the not implemented error exception. Because the todo function call returns the nothing type, which is a subtype of any other type, the compiler won't complain. The parse function is supposed to return password with policy, but throwing an exception is totally valid from the compiler's point of view. There are 2 ways to parse the input: by using utility functions on strings or by using regular expressions. Let's discuss both these ways. The Kotlin Strand library contains many helpful functions on strings, including substring after and substring before. We can use them to solve our task. Let's construct the password with policy object. For clarity, we can provide the parameter names explicitly. The password is a substring that goes after the colon. The letter is a substring going after the white space and before the colon. Password with policy expects a character here, so we should call the single function which returns the character. We assume that our input is correct. If not, single call will throw an exception. But we can also use single or null that returns null if the string is empty or contains more characters. The range goes before the white space and consists of two numbers split by the hyphen. To build a range, let's first take the substring before the white space. Let's call let to introduce a new variable inside a lambda and later return the desired range as the result. We first split the substring returned by the substring before with a hyphen. Then we use the destructuring declaration syntax to assign the result into two variables. Split returns a list of strings as a result, but we assume that the input is correct and there are only two parts. Finally, we convert both lines to ints and build a range using the range2 operator. Let's now call this function to transform each input line to password with policy. We can pass a member reference to the map function. Next, let's display the list of passwords to make sure that the input is read correctly. Of course, in this code, we assume that all the input lines follow the given rules. In real-case scenarios, we should check that the input is correct. Substring after and similar functions take a second argument default to the string itself. It gets returned when the delimiter is not found. ToInt and single also have toInt or null and single or null counterparts. They return null if the operation can't be performed instead of throwing an exception. If you want to write the code that properly checks that the input is correct, you can of course write the corresponding code by hand, but an easier alternative might be to use regular expressions. Let's now implement the same logic using regular expressions. You can see a regular expression describing the input format on the screen right now. First, go to groups of numbers split with a hyphen. Then a letter, one character, a colon, and a password, group of characters. In Kotlin, you use the regex class to define a regular expression. We can put it inside a triple quoted or so-called raw string, so you don't need to escape the backslash character. For regular strings, escaping is done in a conventional way with a backslash, so if you need a backslash character in the string, you repeat it twice. Raw strings are really useful for defining regular expressions. Now let's define the parse using regex function that should match the line against a regular expression, and then build password with policy on the result. We first call the matchEntire function that tries to match the given input against the regex pattern. If the attempt is unsuccessful and the input doesn't correspond to the pattern, matchEntire returns null. Since the result is nullable, let's use the safeAccess to gauge the components of the result. The destructured property returns these components ready for destructuring assignment. We use this result together with let and destruct it inside the lambda expression. We have start and letter and password as parameters corresponding to groups in a regular expression. Finally, we build the password with policy object. As before, we convert start and the end string to ints and extract a single char from the letter string. That's it. Let's again run our program to make sure that the second way to read the input also works as expected. After we read the input, we need to validate whether the passwords meet the given policy. In the first part, we need to ensure that the number of occurrences of a letter belongs to a given range. It's one line in Kotlin. We count the occurrences of letter in the password string and check that the result is in range. In checks that the given element belongs to a range. For numbers and other comparable elements, x in range is the same as writing the following explicit check. Now we count how many passwords conform to the given policy. Let's run it against our sample input to check the result. Yep, we see 2 as expected. Let's now solve the second part of the task. It isn't more difficult. We need to check that exactly one of the positions stored in the range contains the given letter. We can use the Boolean exclusive OR called XOR operator for that. It returns true only if the operands are different. if one of the arguments is true and the other is false. That's exactly what we need here. We check whether the character on the given place in the string equals to the letter. We subtract 1 from range first because the policy starts indexing at 1, but string indexation starts at 0. And then we put XOR and check the same for the second place. Now we are adding the counting for part 2 and running the code. We expect that only one password is valid, and that's exactly what we see in the output. That's it. We discussed how to solve this problem, and along the way looked at string utility functions, regular expressions, operations on collections, and how let helps to transform the expression nicely to the form you need. Please share with us if you find this format useful for you and would like us to provide solutions for more difficult tasks. Thank you for watching!